All right. Hey, everybody. Today we're going to work on solving rational equations. That word says equations. My E looks a little weird. If you want to stop the video right now and copy down these 3 examples, you can do that. Otherwise, you can just copy as we go. So maybe you want to stop and copy these 3 examples. If not, then let's go ahead and dive right in. All right, so with rational equations, common denominators are kind of the name of the game to begin with. So let's take a look at example 1 and think about what would be a common denominator. Well, for a common denominator here, I'm thinking, well, this would factor into x times x plus 3. And then all that's missing here would be an x. And then over here, what's missing is the x plus 3 part. So I'm going to start by kind of like making a common denominator everywhere. Once you have common denominators across the problem, then you can just disregard the denominator and your problem. Wait a minute. If you do something to the bottom, you have to do it to the top. So here I added an x, and here I added the x plus 3. So anyway, then you can just drop the denominator, and you're looking at this. Wait a minute, why does that work? What's going on right now? Well, really what's going on is after you create this common denominator business, what you're going to do is you're going to multiply the top and the bottom by that common denominator. Or no, you're going to multiply both sides by that common denominator. So then here, the x plus 3 and x would cancel. Here, when you distribute in and when you distribute in, x plus 3, x plus 3 cancels. So I'm going to leave out that step where we multiply both sides by the common denominator to get it to cancel out, because I want to get right into the math. All right, so let's solve. 5x plus 15 plus 4x is equal to 8. I have a 9x. I combine those like terms. Plus 15 is equal to 8. Subtract the 15. 9x is equal to negative 7. And then my final answer, x is equal to negative 7 divided by 9. Okie dokie? All right, let's try another one. All right, example 2, does anything factor? You bet your biffy it does. 8 and negative 6, negative 4 and negative 2. So x minus 4, x minus 2. So that, I could make that in my common denominator if I multiplied here by x minus 2s and here by x minus 4s. How do you feel about that? Look good? Looks good to me. Okay, then, like I did in that orange step up above, now you're going to multiply both sides by the common denominator, and it's gone on both sides. So you're down to x times x minus 4 plus 1 times x minus 2 is equal to 2. And then go crazy. This is going to be quadratic. Check it out. Swing everything to one side to set the equation equal to 0. Combine some like terms. X squared minus 3x minus 4. Hey, that's quadratic again. Are there 2 numbers that would multiply to negative 4 and add up to 3? Negative 3, I mean? Yes, there are. So x minus 4 and x plus 1, using the 0 product property, my solutions, you see, are going to be 4 and negative 1. Time out! I need to go back and make sure that none of these would be extraneous. And I see right now, right here, ooh, youch, I have troubles, because if I plug in a 4 right here, now I'm dividing by 0. So x equals 4 is extraneous. My only solution is x equals negative 1. Okay, good work. Last example. I feel like I'm going fast. If I feel like I'm going fast, then yeah, I'm going fast. So maybe slow me down, maybe rewind, maybe just watch me again. Okay, begin by factoring. I see the difference of two squares, x minus 3, x plus 3. And you know, maybe that's going to kind of set the stage for my common denominator. In this first fraction, all I'm missing is the x minus 3. Now, here in the middle, if I rewrote this, this is similar but different. So I'm going to factor out a negative. This negative, I'm going to transfer up here and then just kind of forget about it. All right, see what I did there? I factored out a negative. I moved it up top. That's fine. And now, you know, even things out. X plus 3. So I added an x plus 3 in the denominator. Over here, I added x minus 3. So make sure you do that both top and bottom. I almost forgot. And then multiply both sides by that common denominator. As long as you've got common denominators, they just will cancel out on both sides. So 2 times the quantity x minus 3 minus 5 times the quantity x plus 3 is equal to 6. All right, again, let's solve. This is linear. I don't have an x squared, so it's just going to be, you know, one solution. I'm looking at a negative 3x minus 21 is equal to 6. Rewrite that so I have some more room to work. Add 21. Negative 3x is equal to 27, making x equal to, yep, you're right, x equals negative 9. Okay, now if I plug that in, am I going to get an extraneous solution? Nah, I'm good. If I plug negative 9 in right here, that would be 81 minus 9, which isn't 0, so it's not extraneous. It's all good. Okay, I'm done. We'll practice more tomorrow.